Hey, thanks for joining me. We're going to solve systems in three variables or a system using Cramer's rule, but I'm going to use an alternate method for calculating the determinant. So here's my system. I have 5x minus 4y plus 3z equals 15, 3x plus 2y plus 9z equals 13, 7x plus 6y minus 6z equals 6. Notice that we have three unknowns, x, y, and z. That's what makes this one a more challenging problem. And that means we have to have three equations that are all different. They can't be like the same equation in two different forms. They have to be different equations to be able to come up with the solution. And Cramer's rule says that x equals dx over d, y equals dy over d, z equals dz over d, and that d stands for the determinant. So we're calculating determinants of a matrix, 3 by 3 matrix. Now, there are kind of more standard methods for calculating determinants that you can find somewhere else. I'm going to show you an alternate method for this 3 by 3. I'm going to take my coefficients from the x, y's, and z's in my equations, and that's going to be my initial matrix that I'm going to use to find the determinant. So 5, 6, 7, negative 4, 2, 6, and 3, 9, negative 6. Now those are the coefficients of, in each column, the first column are the coefficients of x, second column coefficients of y, third column coefficients of z. For this method, I'm going to take my first two columns and rewrite them. 5, 6, 7, negative 4, 2, 6. And now here's the process. If you remember what you would normally do to find a determinant, you circle that first number and you cross out that row and that column, and then you take the determinant of this bit down here. And that involves multiplying across down and multiplying across up, and then whatever that answer is, you multiply times the 5. Well, we're going to do all of those multiplications and additions and subtractions, but we're just going to do it in a different order. And here's the order we're going to do this in. We're going to multiply diagonal down, so we're going to multiply down one time, and then a second time, and then a third time. And each of those multiplications, each of those products, we're going to add together. Then we're going to come in and we're going to multiply up 1, 2, 3, and each of those products we're going to subtract. And that's really getting that whole diagonal multiply down minus the multiply up part of the determinant, and then multiply by that top number, the 5, and then you do the negative 4, and then you do the 3. So we're getting all the multiplications in there together, but I think it's a little bit easier to remember and to visualize. So let me show you just one last thing that is going on here. This will, I think, help to kind of understand why we did those last two columns. What we're really doing is we're multiplying 4 times 9 times 7. When we do that, we're really doing 4, 9, and then this 7 here. So we're just kind of going diagonal down, but then we're kind of going around. If you can imagine, just going around to the other side. And then when we do 3 times 6 times 6, it's really, we're just doing 3 times the 6 times 6 there. So it's really the same numbers, kind of in the same pattern diagonally, but it's helpful to have those first two columns rewritten so that we can kind of see everything that we're doing. Alright, so there's the stripes you can see of what we're multiplying. Okay. Let's do this. Multiply down. So 5 times 2 times negative 6 is negative, oh, get my pen right here. Negative 60. And I'm just doing some really basic multiplication. I did it on a cheap little calculator. Nothing complicated, but I think you can imagine that it's going to be a lot of room for error here, because you're just doing so many calculations. It'd be really easy to make a dumb mistake, mistype on the calculator or something. So you want to be careful. You know where your tendency to make mistakes lies. Be careful with the positives and negatives, and multiplying two negatives together equals a positive, subtracting a negative is like adding a positive, and then just be careful with your adding all these together. So we have a quantity of negative numbers that we're adding, and then there's a bunch of positive numbers that we're subtracting. That means the same thing. So I'm going to take my only positive number here, 108, and then I'm going to subtract 60 minus 252 minus 42 minus 270 and minus 144, and I end up with D equals negative 660. Alright, so write that down, set it aside. Notice that that number is part of all three of my answers for X, Y, and Z, so we're going to use that one a lot. Let's go to the next one. We'll set up the matrix here. We're going to take the same matrix, and we're going to replace the X column with these numbers here, the 15, 13, and 6, from what each sentence equaled. And so I've done that, I've already written that in. And then the rest of the matrix, that original D matrix, is going to stay the same. So I'll keep the negative 4, 2, and 6 in the middle column, the 3, 9, and negative 6, the third column, and then I'll repeat. This is just our method for doing the determinant. I'll repeat the first two columns outside here so that I can do my diagonals down easily. 1, 2, 3, and my diagonals up. So now I have it set up. I'll just type it in my calculator and get my answers. So 15 times 2 times negative 6 is 180, and then I get negative 216, 234, minus the diagonals going up, 36, 8, 10, and 3, 12. When I combine those together, adding the positive one and then subtracting all the negative ones, or the ones that are being subtracted, which is almost all of them, I end up with dx equals negative 1,320. Okay, I have enough data to get one answer now. So I'm going to plug this in here. X equals dx over d, so negative 1,320 over 660. And when I type that in my calculator, I get, obviously it's negative, it's a positive number, negative divided by negative, I get 2. So x equals 2. And now we need to figure out what y equals and z equals. We need to find dy and dz using the same method. So for dy, I'm going to plug in the original numbers from my original matrix, the 5, 6, 7 in the first column. Replace that middle column where the y coefficients were with that 15, 13, and 6 from the answers. We've got the third column is still 3, 9, and negative 6. I'll repeat my first two columns, 5, 6, 7, 15, 13, 6. And I'm going to multiply down. 3 times, and then I'll multiply up 3 times, subtracting that second set. So 5 times 13 times negative 6 is negative 390. And then 945, 108 minus 273, 270, and then I always have to be careful with this one, minus negative 340. So I remind myself a minus negative is a plus, so I add the positive terms, and I subtract the negative terms, and I get dy equals 660. Now, most of the time, when you're learning this stuff, they're going to give you nice, simple answers, and so it's kind of comforting to us that we get something that's going to go in so easily. 660 divided by negative 660 is just negative 1. So y equals negative 1. It's important to note that this method is actually most useful in situations where the answers do not come out evenly. So you want to be aware of the fact that you could get really ugly fractions for each of your answers, but oftentimes when we're learning this, we'll be nice and give you easy numbers. Okay, so again I've filled in my original matrix numbers. The 5, 6, 7 are the coefficients of x, negative 4, 2 is 6, the coefficients of y. Now we're looking for dz, so I've replaced the coefficients of z with that 15, 13, 6. Rewrite the first two columns. And multiply up, multiply down, 2, 3 times, and then multiply up 3 times, and we'll get our final answers. This time I get 60, negative 364, 540, minus 210, minus 390, and minus negative 144. That's the 6 times 6 times negative 4. That's positive 144 plus 540 plus 60, and then we'll subtract negative 364, negative 210, 390, and we get dz equals negative 220. So what does that look like? Negative 220 divided by negative 660. And that's not too hard, but it is not a whole number. It's a fraction. It reduces to positive 1/3. So z equals 1/3. The real value of this method is that it's all multiplication and addition or subtraction. All whole numbers or integers the entire way through until you get the final answer, which could potentially be a fraction. If that's what the answer is, that's fine. But you don't have to deal with any fractions at any point along the way. And then I think doing the kind of the diagonals down and diagonals up is a little bit easier method than the kind of more standard steps of doing the determinant of a 3 by 3 matrix, which is certainly doable. It's the same arithmetic, but it's the process of setting it up is a little bit more cumbersome. Well, thank you very much for watching. I hope this was helpful, and have a great day.